I'm just going to go over question 5 from our textbook, which is the redox, the end of chapter exam questions for redox. So part A just wants us to give us the oxidation state for iodine for each of these. So any element, the oxidation state is always 0. So I can be confident with I2. And with HiO3, it's a bit more complicated. Hydrogen's always +1. Oxygen's always -2, but there's 3 of them. And we know that the sum has to add up to 0. So 0 equals +1 plus x, which is what we're trying to work out, -6. And if I rearrange that, I get x equals +5. So the oxidation state of HiO3 is +5. Right, part 2. Complete the balancing of the following equation. So I2 plus 10. Sorry, plus 10 HNO3 gives HiO3 plus NO2 plus H2O. Now, this one on the face of it is quite tricky, because if we look at these chemicals on the right-hand side, there's oxygen in all 3 of the chemicals on the right-hand side, and there's hydrogen in 2 of them. So that makes the balancing quite tricky. So what we want to do is look at the ones that are only in one place on the right-hand side, so the iodine and the nitrogen first. So that's what we want to balance first. If I look at the iodine, there's 2 on that side, so I need to put a 2 there. And if I look at the nitrogen, there's 10 there, so I need to put 10 there. Right, so that all that remains is this number here. So on this left-hand side here, if I look at the hydrogens, I've got 10 hydrogens. We can do this with either the oxygens or the hydrogens, but the hydrogens are less often, so it'll be quicker. So there's 10 hydrogens there. I've got 2 hydrogens there, none in that, and I've got 2x there, where x is a number that I'm going to put in front of the water. So 10 equals 2 plus 2x. If I rearrange that, 2x equals 10 minus 2 equals 8. So x equals 4. So I just need to put a 4. So I've run out of space there. Hopefully you can do it more neat in your notes. Right, B. So it just wants us to write an overall equation here. So overall ionic equation, and identify the oxidizing agent. So we'll do the oxidizing agent first because that's easiest. So oxidizing agent. So we should all remember, hopefully, the oil rig. Oxidation is loss, reduction is gain. So an agent causes something. So if it's causing loss of electrons, it must gain the electrons itself. And if we look at those 2 equations that are here, so if it's gaining electrons, the electrons are on the left-hand side. So therefore, the oxidizing agent is going to be IO3 minus. Right, now I need to do the overall equation. So to do the overall equation, let's write out the 2 half equations first. So I've written out the first half equation. Let's write the second one. So if I look at those, there's 5 electrons in the first one and 1 electron on the second one. So remember, we need the same number of electrons on the left-hand side as the right-hand side. So I need to times that by 5, which means I've got to times everything else by 5. And then I've just got to add them up. So that gives me IO3 minus. The electrons are going to cancel out, so I don't need to include them. Now here I've got 2 iodines, so I need to add them together. And if I add those 2 together, that gives me 3 iodines. And the electrons cancel out. So there's my overall answer. Right, C. So this is going back to our reactions of halogens with sulfuric acid, and unfortunately for a lot of this, we've just got to learn what the answer is. So when concentrated sulfuric acid is added to potassium iodide, we get solid sulfur and we get a black solid, and that black solid is iodine. And it wants us to deduce a half equation for the formation of sulfur from concentrated sulfuric acid. So I want sulfur on the right-hand side, sulfuric acid on the left-hand side, which is So the sulfur in that is SO4 2-. So the sulfurs are balanced. There's only one on each side. I've got 4 oxygens on the left-hand side, so I need 4 waters on the right-hand side to balance that. And then I've got 8 hydrogens on there, so I need 8 H plus on there. There's no charge on the right-hand side. There's a charge of 6 plus on this left-hand side, so I need to add 6 electrons to balance that out. Right, part D. Okay, this is just an identification. Again, you've just got to learn what the products are for these. So when you've got iodide reacting with sulfuric acid, you end up with hydrogen sulfide. Sometimes in this question, a lot of people put sulfur dioxide as that, but the oxidate tells you here the oxidation state is -2. So you could work out that sulfur dioxide is the wrong one. Right, part E. So we are doing the silver nitrate tests for the halide ions here, and it makes a yellow precipitate. And we should know that when we're doing these tests, the precipitates are the silver halide. So in this case, it's silver iodide. So we should know that silver in this case is Ag+. The formula is going to be AgI, and the simplest equation is just Ag+ plus I-. So you're just adding those 2 ions together. It doesn't want state symbols in here, but if we were to put them, it would be aqueous on the left-hand side, and then because this is forming a precipitate, it would be solid. So that's part 1 of E. Part 2 of E. State what is observed when concentrated ammonia solution is added to this. So remember, the chloride dissolves in dilute ammonia solution. The bromide dissolves in the concentrated ammonia solution, but not the dilute. The silver iodide doesn't dissolve in either, so there will be no visible change. Right, part 3. Right, we need. So why do we need to add acid when we are doing the test with silver nitrate? So if we don't add acid, then we get false negatives. So the acid removes ions that would give a false positive. So the best example is carbonate ions, in which case you get silver carbonate, which is a white precipitate. So it gives you a false positive. You would think they've got chloride ions there. Right, the last bit of the question, we've got F. So in terms of electrons, state the meaning of the term reducing agent. So as we said in the earlier part of the question, oxidation is loss, reduction is gain. So if something that's being reduced is gaining electrons, a reducing agent needs to donate those electrons. So a reducing agent loses electrons. That's part 1. Part 2, write a half equation for the conversion of chlorine into chloride ions. So we're just stealing this from the equation above it. So there's the chlorine, and it's going to give the chloride ions. We can take that balancing direct. Sorry, that's at the bottom of there. So we can take that balancing direct from the equation in the top of F. And then I just need to add electrons to balance the charge. So there's a charge of 2- on the right-hand side, so I need 2 electrons on the left-hand side. Right, and then part 3, explain why iodide ions react differently from chloride ions. So if you think about the group 7, which the halogens are in, so iodine is below chlorine in the periodic table. We need to be careful that we're not talking about atoms or molecules here. So it's talking about ions, so we need to make sure that we use the correct term here. So iodide ions, because they're lower because iodine is lower than chlorine in the group, iodide ions will be larger than chloride ions. And because they're larger, there'll be less attraction to their outer electron. And therefore, if we look at our definition of reducing agent, there will be better reducing agents. Okay, that's the last part of the question. Thank you for listening.